Hello. In case any of you haven't heard about it, we are living in unprecedented times and we've all had to pivot our teaching. Now, some aspects of that have been reasonably straightforward, but one aspect which is still causing a lot of headache is assessment and especially exams. As an illustration, I have plotted here the cumulative distribution of marks for two very similar exams. So one in 2019 was face-to-face and invigilated, and one in 2020, which had to be moved online at reasonably short notice. Now, because the exam was moved online, I made it a little bit harder, and it shows by the distribution of marks here at the top end, but at the bottom end, the marks have wildly improved for most of the class. Now, there could be many possible explanations for this, and I'm not claiming that some students were cheating, but it does show that online exams are different. So what can we do about it? One solution is online proctoring, where students are recorded taking the exam. Guess what? Students absolutely hate it. So the university ruled that out from the get-go. And what's left? Well, first of all, you can write new questions that require more understanding and thinking and less parroting of facts, as well as that you can try to minimize the extent to which students are going to share their answers. So the framework for this is Moodle. Moodle is the learning management system in use at my university. It claims to be the world's most popular learning management system. And one of the nice things is that it's open source, meaning that there's been a lot of community contributions over the years. The one big strength of Moodle here is the quiz engine, and that offers a lot of possible question types. So it does include fairly standard things like multiple choice, true, false, matching pair, short answer, numerical, and so on. So short answer has got wildcards, numerical gives you a margin of error in the numbers in the answers. Then you can do drag and drop, for example, to complete a paragraph or to annotate a graph. You can close is some sort of a markup language for building questions. You've got some totally free-form questions, like ones that require the students to write text, and you've got to mark it manually or make a drawing. And then you've got questions that use math. So you can have calculated, where the inputs of the question are generated randomly, and the students have to apply a formula to get an answer, which is tested. Stack allows writing formulas. That's good for maths. Code runners is good to write snippets of code, which are automatically tested. And the one that I'm going to focus on is formulas, which is like the calculated question, but on steroids. So for most of my exams, I've used a fairly traditional approach. I set a number of essay questions that require a structured answer, questions that articulate an argument rather than just listing facts and parroting lecture content. And with each student's questions, they are drawn randomly from a pool of questions, so students don't all get the same questions. And that had to work reasonably well. So different students get different questions, and all the questions don't just require pasting it the lecture slides, but they require some thinking and some demonstration of understanding. However, there's still issues with this approach. For a start, the questions all need to be marked manually. But most importantly, if I just ask essay questions which require the students to type their answers in a text box or something like that, it's not suitable for answers that require graphs or drawings. And a lot of questions in bioinformatics do require graphs or drawings or equations or flowcharts, matrices, trees. Now, the context for this story is my Introduction to Bioinformatics course. It's a second-year course, and it's meant to explain to the students what it is that they signed up for when they enrolled in a bioinformatics degree. Pretty much the course goes through the different areas of bioinformatics, like sequence analysis, structure, and so on. And for each area, it discusses the biology, it discusses the problems, discusses the nature of the data, and then from there it moves into the computer science and discusses some possible solutions, just as examples. And really what I want to demonstrate in this course is the process of bioinformatics, of going from biological questions to computational answers. So as part of that, I discussed some simple algorithms as illustrations. And in my part of the course, the three algorithms that I've been demonstrating are sequence alignment by dynamic programming, phylogeny using UPGMA, and a simple graph-based sequence assembly based on k-mers. Now, I demonstrate all of those algorithms in the lectures and tutorials, and for the exam, I want the students to demonstrate that they understand how the algorithm works. So traditionally, the way I did that was to give them, here are two sequences, align them using the Smith-Waterman algorithm, show your workings. And really, the show your workings is the key point there, where they've got to demonstrate and show that they're using the algorithm by hand on a little toy problem. But it's hard to set that online because the show your workings part requires graphs, which is very hard to do in just a text box. So I could just ask for the answers, but the issue there is that it makes it very easy to share the answers between students. Now, I do like to think that my students are honest, but I don't want them to feel like they are given an ethical quandary when they start the exam, and I don't want them to feel that they're disadvantaged for being honest because some students may not be as honest as them. So I felt that Moodle, in all its amazing quiz engine, would have some sort of a solution they could try to use to make it harder to cheat, essentially. And the answer came in the formulas questions. Now, the formulas question is, the description is rather sparse, but to cut a long story short, after reading a lot of tutorials and watching YouTube videos and all sorts of things, I was able to tweak it to the point where I could use it for the simple algorithms. And this is one example of a question here. This is one that pretty much tests the Smith-Waterman algorithm. Now, the formulas question really requires numerical answers. You can tweak it to also require multiple choice, to provide the answers as multiple choice if you want text, but really what it wants is numbers. So I couldn't ask the students to do an alignment and to give me the alignment, but I can certainly ask them to give me the alignment score and to fill in the dynamic programming matrix to show that they understand how the algorithm works. And the key thing, because I'm using the formula question, the question itself, all the numbers, all the parameters are automatically generated. So the scoring matrix is automatically generated. The gap penalty is randomly generated, and the sequences are randomly generated. So every student gets a different combination of scores, gap penalties, and sequences. And that means that it makes it much harder for them to actually share their answers. So how does that work? This is what it looks like behind the scenes. And the key work is done in this variables section. So the random variables section here is where the randomization takes place. And you can create random variables either by picking a number randomly from an array or from a range, or by shuffling an array. So that is where the randomization comes in. And then you have a section on global variables, which is where the magic happens. And this is pretty much, you can calculate new variables from those randomly generated variables based on a series of fairly standard mathematical operators. So here, for example, I'm generating the sequences. So I've got one sequence of 4 characters, one sequence of 3 characters, by drawing from an array which has been shuffled. And here I'm generating the scoring matrix, again by picking scores from a shuffled array. As I scroll down the global variables section, I can also give the formulas to calculate the answers. So here I have the formulas to fill in the scoring matrix, and here I have the formula to calculate the alignment score. So based on that, I can randomly generate a series of values, and I can use that to generate the parameters of the question as well as the answers. And then as I scroll down the question editor, I have an HTML editor that allows me to write the question, and within that HTML editor, I can call the variables that I've previously calculated, either as input in the question. So here I've got my scoring matrix, I've got my gap penalties, I've got the sequences here, or for the answers. So here I ask the students to fill in the dynamic programming matrix, and each of those is a placeholder for a text entry box where they're going to enter a number, and that number is compared to the answer, which is itself a variable that has been previously calculated. So by using this formula type question, I can create something like this, where the scoring matrix, the gap penalty, and the sequences are all randomly generated. Every student gets a different combination, and they have to fill in the scores, and they have to calculate the alignment score. Now, I'll also use that to test UPGMA. So in the case of UPGMA, I can't ask them to draw the tree because, again, it does not let me, you can't use a drawing as an answer. But I can ask them to calculate the distances, the branch length, based on a randomly generated distance matrix here. For the graph-based sequence assembly, I had to use multiple choice in order to get the answer. But in this case, the sequences and the k-mers are all randomly generated. So different students get different one of those. So I hope this did not sound too much like a commercial for Moodle. Certainly not an ideal solution. As you see, I can't ask them text answers. It's got to be numbers, or you can sort of tweak the thing to require multiple choice answers. And it took me a lot of time to get here, browsing through the documentation, and it's still limited. But now that I've done it, and I've spent a fair bit of time tweaking the questions, I'm really feeling quite happy about it. It serves its purpose in that each student gets different sets of values, and if I couple that with setting up a time-limited quiz, it reduces the chance of students working collaboratively. Not that I'm saying that it happens, but my colleagues tell me that it does. But there's other advantages. One of them is that you can also use that for formative assessment. So the goal is for the students to learn how to do this. And with that framework, I can give them the question ahead of the exam, and they can practice with it, and they can actually learn the algorithms by practicing and getting instant feedback on the answer. And finally, the questions are auto-marked, so less marking for me. Again, not a big deal. I used to do it on paper exams, and that's what I'm paid for. But doing less marking means I have more time to spend on other things, like marking other exams, or having important academic discussions with my colleagues regarding cheating students. Now, this is not the only solution. One of my colleagues used something called Moodle.sty, which is a plugin that allows writing Moodle questions in LaTeX. And because he's really smart, he wrote a bunch of scripts in LaTeX that allow generating questions, again, randomly, and building a huge question bank of automatically generated questions and then the students can get randomly selected questions from there. But that still requires manual marking, but that's also a much more flexible option. Anyway, thank you very much for your attention. I hope this is useful to some of you. If some of you are using Moodle for teaching and want to have a look at my questions, I'm very happy to share them. And if you find other clever ways to use Moodle for bioinformatics, do also let me know. That would be very useful. Thank you.